screen is visible?
Yes, ma'am.
Thank you, ma'am. Thank you. Okay. So I welcome all the participants for the course. Today we are going to deal with classification and regression. Okay. So the objective of the session is to make you known about the basics of classification and regression. Okay. And the outcome of the session, the students may be able to understand the basic concepts behind classification and regression. Okay. So these are the outline of today's session. First, we will be seeing what is meant by machine learning and what are the applications and what are the types of machine learning and what are the different kinds of data, or in other words we can say what are the different kinds of variables are there, and what is meant by classification, we'll be seeing that, and what are the examples of classification and what are the steps involved in classification process and what are the algorithms under this classifications are possible, and we'll be seeing the regression. And under the regression, we'll be having two types. One is linear regression and the other one is logistic regression. So with this, we'll wind up today's session. Okay. So already we have seen what is meant by machine learning and what are the different types of machine learning and what are the steps involved in machine learning and what are the applications where we can apply this machine learning in yesterday's class. Just let me recap and continue with today's class. Okay. So machine learning is a field of study that gives the computer the ability to learn without being explicitly programmed. So in other words, we can say this machine learning means given a data, user will be given some input data. So you have to train that with that particular data in the machine. You have to train the machine with the help of this training data. And upon training, then you have to come up with a prediction based on the given data. So machine learning model comprises two phases. One is training phase and the second phase is prediction phase. Okay. So in the training phase, the user will be given the training data set, and with the data set, it has to be trained. The machine has to be trained with the help of this input data set. In the second phase, so with the training, model, after creating the classifier model, it has to predict the correct output. That is the prediction phase. That is the second phase. Okay. So machine learning means making the prediction based on the input data given. Okay. So machine learning model intends to determine the optimal structure in a data set to achieve an assigned task. Okay. So it results from the learning algorithms applied on the training data set. Okay. So learning algorithms are nothing but the machine learning algorithms. Okay. So that will be applying this algorithm on the particular given training data set. So in short, we can say that training data will be given to the user. Then on applying the machine learning algorithm, the model will be designed. Okay. So these are some of the applications of machine learning. They are speech recognition, effective web search, recommendation system, computer vision, spam filtering, information retrieval, computational finance, fraud detection, medical diagnosis, stock market analysis, structural health monitoring. So some of the applications are listed with these applications or the examples where we can apply the machine learning algorithms in these applications. Okay. Okay. So added to this, Google machine learning is everywhere at Google, and Google Translation, Google Voice Search, Okay, that is voice recognition system is based on machine learning algorithms, and then Google Photos. So photos, how you can classify the images or the pictures or the photos. So all you can apply the machine learning algorithms. Okay, and Gmail. Okay, and Google Maps. Okay, so all these are some of the applications where we can apply for all these applications. We can apply the machine learning algorithms. Okay, so what does machine learning mean? It's a subfield of computer science that gives computer the ability to learn without being explicitly programmed. Okay, so as I have already told that first phase is training phase, and the second phase is the prediction phase. Okay, so training phase, you have to divide the given data set into training data set and testing data set. Okay, so using the data. Then prediction means you have to answer the questions that is going to be called as a prediction model. Okay, so as we have already seen, there are three major types of machine learning problems: supervised, unsupervised, and reinforcement. And add on to this, we are having semi-supervised, that is a combination of supervised and unsupervised. Okay. Okay. Let me see the kinds of data. In other words, we can say how we can classify the variables. Okay. So variable or data. Okay. So in general, the variables can be divided into two types. The first one is categorical, otherwise called as qualitative variable. The next type is numerical variable, otherwise called as quantitative variable. Okay. So again, the categorical variable is further divided into two types. The one is nominal variable, the other one is ordinal variable. And the numerical variable, that is quantitative variable, is divided into two types. One is discrete variable and continuous variable. Okay, so you'll see what is meant by nominal variable. Okay. So nominal data or nominal variables, these are the variables where the categories are just named. We call that as a named category. Nominal means named. Okay. So for example, the category can be red, green, blue, apple, oranges, bananas, kiwi fruit, likewise. Okay. And ordinal data or ordinal variable is where that categories, but there is some kind of order should be maintained. For example, that is the categories with an implied order is called as ordinal variables. Okay. For example, you can have big, medium, small. Okay. So these are ordered. Okay. From the high level to low level, big, medium, small. Okay. Likewise, best, preferred, acceptable, maybe, no way. Okay. So these are some of the categories which have been maintaining some order, some particular order. Okay. So these are categories, and there are some implied order should be maintained with them. Okay. So these are all about the categorical variable. Coming on to the numerical variable, that is quantitative variable. So it is having kinds. One is discrete and continuous. So discrete will be having only the particular numbers are allowed. Only particular numbers are allowed in the discrete variable. Okay. And for example, we can say usually you can have whole numbers only. Okay. So like how many cars? Okay. The answer will be 5 or 7 cars, like that. Okay. And how many children? Number of children. So that will be the answer for this question will be number of children 3, like that. Okay. So discrete means only the particular number is allowed. Numbers are allowed. Okay. Then coming on to the continuous variable. So the variable where the value will be expressed or represented in ranges. Okay. The value in ranges are allowed. So any numerical value can be. Okay. For example, mass of the cars, children's height. So any numerical value is possible. So that is called as continuous variable. Okay. So this is all about the kinds of variables. So whatever the input given to the user, the input variable should be classified as categorical variable or numerical variable. In specific, we can say nominal or ordinal or discrete or century. We have to classify based on the given values, input values. Okay. So here, take up one example: age, gender, and income. So this is the data set given to the user. So consider like that. So age, these are all the real values. Okay, and we call these age and gender as features. Okay. So features or input variables, we can say, or they are called as independent variables. Independent variables. Okay. So among these three columns, we can calculate the income or predict the income, not calculate, predict the income based on these two features. Okay. So that variable is going to be called as label. Label means the output class or the output category or the target class. We call that label variable means dependent variable. The output variable is going to be the dependent variable, and other than the features or other than the input variables, we call that as the independent variable. Okay. So this income variable always depend on the independent variable, these age and gender. So we call this income as a dependent variable because the values of income always depend on the age and gender. Okay. So coming on to the gender, the values of gender field or gender feature, the possible values may be male and female. So some category has been maintained here. In other possible values could be entered for this gender. So we call this gender as a categorical values. And this age is real values. Okay. And this dependent variables, these are the values to be predicted. So the same example which we have seen in the yesterday's session also: age, kilometer driven, fuel type, car type, selling price. So among the 5 columns, we are going to classify which one is the independent variable and which one is the dependent variable. Okay. So independent variable means the input variable. Features, input features, we call that as well. Okay. Selling price is going to be called as a dependent variable. This we call it as a dependent variable because this the other is we call this dependent variable as a label variable. Label means this is the output class or the category target class, we can say like that. Okay. So this selling price is going to be predicted based upon the input feature: age, kilometer driven, fuel type, and car type. So we call the selling price as the dependent variable. All these 4 are called as independent variable. So first we have to classify. If you are given a data set, you have to classify which one is the dependent variable, that is your target class or the output class or the label. All are in the same. So you have to identify which one is the labeled variable and which one is the independent variable. Okay, first you have to do that. Then, so here age, kilometer driven, and the selling price, all we call that as a continuous variable. Okay, and fuel type and car type, there is no other possible values for it. Okay, so diesel, petrol can be the only possible category for the fuel type. Okay, and car type also there is no other possible values for that. So these 2, fuel type and car type, belongs to the category variable, and all these other 3 columns belong to the continuous variable. So continuous, it will be any numerical value. is possible. Okay. So coming on to the learning types, learning algorithm types, as we have mentioned earlier, supervised learning, unsupervised learning, and semi-supervised learning and reinforcement. Already we have seen that. Okay. Moving on to the supervised learning. So we are having the examples for supervised learning are classification, otherwise called as categorization. Okay. And the next example is regression. So classification and regression belongs to the supervised learning, and clustering and dimensionality reduction algorithms belong to the unsupervised learning. Okay. So clearly note that regression algorithms will be having the continuous values and the classification will be having the discrete values. Sorry. Okay. So already we are saying continuous means if any numerical value is possible, that is, the value will be specified in ranges. That is called as continuous. Okay. Discrete means you will be having a particular number or allowed. That is whole number like that. Okay. That is called as discrete. So classification will be having the whole number value. Okay. Likewise, discrete, there is clustering will be also having the discrete values, and dimensionality reduction will be having the continuous values. Supervised means learn through examples. That is, the desired output, what we are going to predict, will be known to the user. Okay. So it will be that is that a cat or a dog? Okay. Or these are some of the predictions. I can apply the prediction. That is, whether you have to, the user is given a task to predict whether the given picture is cat or a dog. And next, in that case, you can go for applying the supervised learning algorithm, that is classification algorithm. Okay, or these emails spam or not. You have to go for classifying these two. Okay, predict the market values of houses. So given the inputs like square meters, number of rooms, neighborhood, etc. So all these are the examples of supervised learning. So under the supervised, the best examples are classification algorithm and regression algorithm. Already we have seen that. Okay. So all classification, the output will be is all about a discrete variable. So discrete means you will be having a numbers. Okay. And regression means the output is going to be continuous. So price and temperature will be ranging values, will be having the ranging values. So the output of the regression algorithm will be continuous. Coming on to the unsupervised, there won't be any desired output. So the user won't be having any output or any labeled variables. Okay. Learn something about the data. Okay. So I have photos. The examples for unsupervised learning algorithms are, I have photos and want to put them in 20 groups. So you are having some collection of photos. Now we are going to group the photos in such a manner that you are going to group it into 20 groups. So in that case, you can apply the unsupervised learning algorithm, that is called as clustering. Clustering algorithms you can apply for that. Okay. So I want to find the anomalies in the credit card usage. So what is the problem when using credit card? So the patterns, usage patterns of any customers. So in that case also you can go for grouping the customers. Okay, by applying the clustering algorithm. Okay, see here. So always the clustering algorithm is all meant for or useful for learning the structure of the data, structure in the data. Okay, And you can also go for reducing the dimensionality, and you can also have the hidden correlations also. So with this collection of inputs, you are going to have three groups: red, blue, and green. Okay. Comes the reinforcement. So reinforcement, already we have seen that in yesterday's class, that agent will be interacting with the environment and watches the result of the interaction. Okay. So here the agent is going to be the dog, and the reward is going to be the biscuits. Okay. So based on the environment, the agent is going to interact with the environment, and the agent will be learn from the mistakes. Based on the feedback of mistakes, the dog, the agent will be rewarded. Okay. So this is a rough skeletal diagram of a machine learning process. So past data, there is with the known outcome, known outputs is passed on to the machine learning algorithm. Okay, and we have to design a model. Okay, design a model. Once the model is completed, you have to feed any other new data, so that the model has to predict the correct output. Okay. So these are the steps to solve the machine learning problem. First, we have to go for data gathering, that is collecting the data from various sources, collecting the relevant data from the various sources. Then data pre-processing means clean the data and convert it into a usable form. And feature engineering, that is feature extraction, making your data more useful. So the interesting features alone will be extracted from the collection of features. Okay, and you have to go for selecting the algorithms, machine learning algorithms, and train the machine. Okay, so selecting the right machine learning model. Next, making the prediction, that is evaluating the model. So whatever the model you have designed, you have to go for evaluating it. So far we have seen just for the recap of the yesterday's session. Okay. So now coming on to the classification, what steps involved in classification? We will be seeing that. Okay. So classification is the task of identifying the set of categories. That is, if you are given an input variable, you have to go for identifying or predicting or identifying the output variable and input variable. Okay. Categories means the output variable. Okay. So it is decided on the basis of the training data set that you have that is given to the user. Okay. So the example of classification, we can say classifying the email, whether you are having a spam email or not. So the task is given to you. You have to classify what are all the emails or spam emails or not a spam email. Okay. And next, classifying the flowers of a particular species like a iris data set. Okay. This iris data set is available in machine learning repository. Then you can take that iris data set and work up for the and apply some classification algorithm on it. Okay, and classifying a credit card transaction is either a fraudulent transaction or not a fraudulent transaction. Next, we can go for a face recognition. Okay. So these are some of the examples of classification. Okay. So supervised learning, the best example is classification. So given a set of inputs, The task is going to be the prediction one. In classification problem, the prediction is going to be the categorical response. Okay. So already we have seen categorical response means it belongs to some category. Okay. So category means it may belong to some red, green, likewise, whatever the color category or car category, likewise. Okay. So in classification problems, the output is predicted as a categorical response based on the sum of the set of inputs. So the machine predicts one of the values in the set of values. In other words, we can say the output variable is a category. Okay, such as yes or no, or authorized of a fraudulent. Some examples are is the sperm male or not. So based on the input, it has to predict. Okay. So here the question or the task given to the user is it has to classify the given male is whether it is sperm male or not. So based on the inputs, mail ID, IP address, subject of the mail, and timing. So all these are the input of the for this task. The prediction is sperm male or not a sperm male. Okay. The next example will rain today. So based on the input questions, that is input humidity, temperature, wind speed. So it has to predict whether it will rain or not. This is the classification problem. Okay. So this is yes or no type questions all belongs to a categorical response. Okay. We call this as a binary classification because so the two output classes are there. So one is yes output class, the other one is no output class. So the output variable, if we are having two values, means we call that as the binary classification. Okay. So it can also have multi-class classification also. So the response will be chosen from more than one class. For example, we can say that if the picture is cat, tiger, or dog. Suppose if this is the case, means the user has to identify or predict the output classes classified as cat, tiger, or dog. So more than two classes are there. So this we call that problem as a multi-class classification. So coming on to the regression, in regression problems, the output is predicted as a continuous variable. So in the previous case, in class one set of inputs. In regression, the output is predicted as a continuous response based on the set of inputs. Okay, that's the difference between classification and regression. So for example, so we can predict what is the price of a house in a specific city. So based on inputs like number of rooms, age, area, so you have to select the suitable options to see the continuous response. So continuous variable means already we have seen continuous means there will be a value is any numerical value is possible having the range of the value can range from one value to another value. So that we call it as a continuous variable. So here in regression you will be having the continuous output value. multi-class classification, so you have to identify more than two classes. Okay, the classification is done between the multiple classes. That means you are having some that is more than two number of output classes. That we call it as a multi-class classification. Okay. Okay. Let's see what are the steps carried out in classification. First, we have to divide the data set into training data set and test samples. So we can say data set or samples. Okay. Training sample, testing sample. Okay. So first process, we have to divide into two, training sample and testing sample. Next, we have to train the classifier using the training data set. Next thing, test data set. Okay. Next, you have to analyze or finalize the model with the help of some performance metrics. Next thing, improve the model using some error analysis. The first process is you have to divide the training data set and testing data set. For example, if you are given a 70,000 samples or given to the user, consider like this is the situation. So now you are going to split the given data samples into training set and testing set. Okay. So now the training set is going to contain 50,000 of samples.